In our previous video, we discussed the syntax that was required to declare and assign values to a variable. However, there are some additional rules when it comes to the actual naming conventions of our variables that we need to follow. The first rule is that when we're creating a variable name, we can only use alphanumeric values along with the underscore character as possible things. So for example, we cannot name a variable something like factorial with an exclamation point at the end. That exclamation point is not considered acceptable. Any amount of lowercase or uppercase or digits is allowed, with one small exception that while numbers are allowed in the naming of your variables, you can't actually name a variable starting with a digit. For example, if you had a whole bunch of numbers in your computer program and you were naming them things like number 1, number 2, number 3, that's acceptable because the 1, 2, and 3 would come at the end of the variable. However, something like the numeral 1, 1 number, 2 number, 3 number, those would be unacceptable variable names if they started with that numeric digit. Now, an underscore is actually a valid character for starting a variable name. However, it's pretty uncommon to see that happen. The underscore really is a permissible character because spaces are not permissible characters. Remember that spaces mean something to our IDE. They separate various words for the compiler. So the underscore is really there to act as a space for you visually, for your eye, to help with readability. Perhaps something that I should have started with is that the purpose for these values being permissible for naming variable names is that variable names should be helpful and informative in describing what is being stored in that variable. For example, if I were creating a variable that was going to hold a driver's license number, we might want to name that variable something like license number. It should be noted that when naming a variable something that includes several words, for example, license number, some people opt to use an underscore to separate the words license and number, while others prefer to use what's called camel case, where the first word, license, would be written in all lowercase text, but then the word number would begin with a capital N before writing the rest of the word in lowercase. And you can see a visual of that camel case expression over here. Which method you use is not of particular importance. There's no rule about it. It's just a convention. You should choose one that you like. And then what is important is you should be consistent within your own code. This will help you later on as you're trying to remember the names of variables that you've created, and it'll help others if they're the ones reading your code. Variable names are case sensitive, so when you're using this camel case, getting the capitalization correct is important. Over here is an example of a computer program where I've defined a handful of variables. The first variable I've declared is the variable pi, and I've assigned it a value of 3.14159. I've then defined a variable named radius and assigned it a value of 2.0. I will note that it would be perfectly correct to omit that decimal place and define the radius as just being the number 2. It's not the decimal point following that 2 that makes the variable radius into a double. It's this declaration of the data type of the variable radius right here that ensures that the variable is a double. However, it is a good programming practice to include the decimal point and the 0 to align the value that you're assigning to the variable with the data type you've declared for it. Last but not least, I've created a new variable named area that is assigned a value. However, the value that is assigned to area is not explicitly typed out and is rather assigned based on the values that we've already stored within the variables pi and radius. For the remainder of our program, even without us as programmers knowing the exact value of pi times 2.0 times 2.0, that value has been computed and is stored inside the variable area. If we did wish to see that value, we could go ahead and ask the computer to print it to the console, where we would see that pi times 2 is roughly 12.5664. Now, one of the last things that we're going to talk about today is taking a variable and reassigning it a different value. Let's imagine that we now wish to know the area of a circle with radius 3.0. There are several ways we could accomplish this with the program we have thus far. One way would be to define brand new variables, like radius 1 and area 1. Those are perfectly acceptable variable names according to our naming conventions. In writing the program this way, we now have 5 different spots in memory designated to storing our 5 different variables: pi, radius 1, area, and area 1. Now, memory really isn't of the essence in a program about this size, but at some point, as we become advanced programmers, memory could be of the essence. So if we wanted to compute the area of a circle having radius 3 without taking up these 5 spots in memory, we could simply return to the original variable radius and reassign a value of 3 to it. In order to do that, we simply recall the variable radius and reassign it this value of 3.0 instead of a value of 2.0. Next, let's ask the computer to print out the value of the area to the screen. Before I hit compile, make a prediction about what you think will be printed to the screen, given what's in our IDE over here. I'm now going to run the code. If you predicted we would see printed to the screen the area of a circle with radius 2 and the area of a circle with radius 3, you're incorrect. And why is that? It's just because computers are incredibly literal. While we've updated or reassigned a value to the variable radius in line 14, we never told the computer to then update the value that is held within area based on our new radius value. If we wish to do that, we need to add a line reassigning a value to area based on the new value that's within radius. After we add this line of code and make this change, we do in fact see printed to the console the area of a circle with radius 2 and the value for the area of a circle with radius 3. I'd like to return one more time to this line 14 where we reassigned a value to the variable radius by typing in another value we wanted it to be equal to. Sometimes what we wish to do is change the value of a variable based on another or based on even itself. For example, perhaps what was important to us in considering a value for a radius of 3 was to say, take whatever the radius was equal to before and add 1 to it. This can be accomplished either by us doing the calculation directly, as we did before, or by making the computer do that work. For example, if I now wish to take the current value of radius and add 1 to it, I could do that in the following way. Line 19 shows a way to take the value currently within radius once the flow of control reaches line 19 and add 1 to it. This is a lot more clear if you're reading that equal sign as is assigned a value of. When we mathematically read the statement radius is equal to radius plus 1, it sounds false to us. No number is equal to itself plus 1. However, what does make sense is saying that radius, the variable, is assigned a value of radius plus 1. The way that this line is executed is not from left to right as we originally think, but the value to the right of the equal sign or assignment operator is executed first. This value is first computed, and the resulting number is then stored in memory in the location for radius. So the lookup of what is currently in that spot in memory happens before the reassignment. That means that by the time we've reached line 19 in this program, we will look up the value that's currently in radius, namely 3, and we'll add 1 to it, coming up with a value of 4. This value of 4, we then eliminate the storage of the number 3 within radius and overwrite it by storing this value of 4 inside. And we can double check that that happens by printing out our radius to the screen, where we see the number 4. This idea of taking a variable and adding 1 to it is so common in C++ that there are actually several shorthands to help with readability. The example we just saw with the variable named radius was radius is assigned a value of radius plus 1. That's a perfectly valid way to increment the value within radius by 1. However, because it can read so awkwardly, there are 2 alternative notations that you can use in C++ to accomplish the same thing. The first is to say x plus equals 1. This is a shorthand for x is assigned a value of x plus 1. And similarly in C++, you can increment by 1 by simply typing x plus plus. Now this x plus plus notation is unique to C, and in fact, the programming language that was very commonplace before C++ was called C. So this shorthand is the reason we talk about C++ as kind of the next programming language that came after C. That plus plus notation, which is unique to the C programming language, is somewhat unique also to the operations of addition and subtraction. X plus plus is a valid line of code in C++, as is x minus minus, but things like x times times are not allowed. The plus equals operation, however, is more generalizable to both subtraction, multiplication, and division, and these are shorthands that you might see or wish to use in C++ programming.